please open their book to chapter 14. We'll go ahead and get started. Probability is defined as the long-run relative frequency of an event occurring. The result of an event is called its outcome, and outcomes are considered independent if each one does not affect the outcome of the other. Now, to find the additive probability of two events occurring, we use this over here. See, the probability of A union B, which is probability of A plus B minus probability of A intersection B. And for the multiplication rule, for independent and dependent events, we'll use probability of A intersection B equals probability of A times probability of B given A. For independent events, that simplifies to probability of A given times probability of B. Now, for homework, I would like Ali to go ahead and provide us with a practical example of a real-life use of probability in his everyday life.
Yes, I calculated the probability of getting wet at the Pearland Town Center water fountains, and I chose a spot where there were 4 consecutive fountains spraying at one spot. And what I did is I blindfolded myself and walked across them 20 times, so 20 different trials. What I found was that out of the 20 trials, 60% of the time I got wet, or out of the 20 trials I got wet 12 of the times. And so from that, we can conclude that the statistical probability from my sample of getting wet from the Pearland water fountains is 60%. Yes.
Go. Got lucky. Yeah. You can't walk fast. Oh, he barely missed that. Yeah.
So why don't we go ahead and take a look at the histogram of Ali getting hit by the water. Now see, all over here we can look at this histogram. Now it's really skewed. You can see this very skewed. There's a lot of skewness to the right of this graph as he got hit most at two times versus 1, and from there it just sort of goes down to the right. That's about it. Okay, good job, Ali, I guess. I don't really see the point to that project, but let's move on anyway. Our next topic will be over experiments and experimental design. So an experiment manipulates factor levels to create treatments, randomly assigns subjects to these treatment levels, and then compares the responses of the subject groups across treatment levels. So I'd like for homework Sam to go ahead and set up an experiment to show us various treatment levels and just go ahead and do a set proper report for the class.
For my experiment, I dropped $1 bills while walking down a street to obtain a proportion of the people that would return the dollar bill. The treatment was a dollar bill being dropped. There were 2 outcomes for my experiment. The bill could be returned, or the person could not return the bill. 14 people took the dollar bill, and only 10 returned the dollar bill out of the 24 trials we conducted. Proportionally, approximately 58% took it, while only 42% returned it.
Okay.
You crumpled up my dollar. We're 12. Only 2 of the 5 people have returned. 2 of the 4 people have returned it, and this is our 5th try. Looks like Ron dropped the dollar. The guys picked it up, and he gave it back to them. We're trying to come back.
I'm tired.
Y'all dropped your $1.
Was that their dollar? I think that was their dollar.
What a great problem! So now let's go ahead and take a look at the sample survey, chapter 12. Let's see. Sample survey is a study that asks questions from a sample drawn from the same population in hopes of learning something about the entire population. And the population is basically the entire group of individuals or instances about whom we hope to learn about. Sample is going to be part of that population, and there can be various sorts of bias, such as relying on voluntary bias, undercoverage, non-response, and response bias. So for today's homework, I'd also like Paulo to go ahead and conduct a survey trying to minimize the amount of bias in his project.
I did a completely random survey to find out how many people like coffee.
Yes. So you like coffee? Yeah. Okay, thank you. Do you like coffee?
Alright, thank you.
Do you like coffee? Coffee. Yes.
Alright, thank you.
Thank you.
Yeah.
Do you like coffee?
Yes.
Okay, thank you.
Out of the 10 people I asked the question to, 9 of the people said they like coffee. Therefore, I can conclude that there is a 100% probability that 90% of people in the world like coffee.
No, you fool. That's wrong. You just lost points. Not only was your survey entirely biased, but your population size was nearly way too small. You surveyed people in Starbucks about whether they liked coffee and therefore skewed your results. So the only conclusion you could possibly make is that 90% of Starbucks goers like coffee.
Because my survey was so horribly designed, I decided to make another one. I decided to test whether or not people wash their hands after using the restroom. I decided to go to a local movie theater and count the number of people who wash their hands after either using a urinal or a bathroom stall. I used a sample size of 34 this time instead of 10, and 28 of the 34 people washed their hands. That's approximately 82% of the sample. Because taking video in a bathroom is probably illegal, I decided to exclude video for this portion of the experiment.
Good job, Paulo. That survey was a lot better. Now, you guys all have a lot of work to do, so why don't you all go for it and model the world with stats.